Inverse functions. Inverse functions are defined to be a reflection over the line y equals x. Now y equals x is this diagonal upward sloping line right there. And there's probably a lot more going on than you really need to understand, but at the very elemental level, the very beginning of this, if you're trying to find the inverse, all you're going to do is swap x and y. So to find the inverse of point 2, negative 1, they're just simply going to swap places. So that point's inverse becomes negative 1, 2. So negative 1, positive 2. And the inverse of 1, negative 3 is going to be negative 3, 1. They're just going to change places, negative 3, 1. And if you look at it, you can see how they're a reflection over that line, like they're at equal distances away from that line. Okay, so to find the inverse of 5, negative 4, that's just going to be the inverse of, you're just going to swap those numbers, so it becomes negative 4, 5. The inverse of negative 8, 324 is 324, negative 8. If you're given a list of points, it's no different. If you're given a function with the x values of negative 3, 0, 7 and the y values of 8, 2, negative 4, that means its inverse, you just simply swap x and y. The x values would be 8, 2, and negative 4, and the y values would be negative 3, 0, and 7. And yes, the order does matter. 8 and negative 3 need to be together, 0 and 2, and negative 4 and 7. Okay, that is just looking at individual points. Now, you've already learned how functions represent an infinite number of points at a time. So say these points had actually represented a function and we wanted to come up with the inverse of that function, something that would give us a table of values to look more like that. Well, since with individual points we're looking at swapping x and y, that's what you're going to do to find the inverse function. Now the inverse function has this notation. So once you have it, if you see y to the negative 1, that means that's the inverse. Alright, our first step is to swap x with y. Now I don't have a y here, but you guys know that f of x is functionally y. So we're going to swap x and y, and I'm going to rewrite the same thing with x and y change places. So I have x and y. So what I'm going to be solving is x is equal to y plus 6 over 2. So I swapped x with y. Everything else stayed the same. You see the plus 6 is still there, the 2 is still underneath. And then next I'm going to solve for y. So I've got this y right here that I want to get by itself. So what I'm going to do first, I'm just going to use inverse operations to solve. Using inverse operations, since I'm dividing by 2 there, I'll then multiply both sides by 2 and get that 2x is equal to y plus 6. Now remember, I'm trying to solve for y. So subtract 6. And I get that 2x minus 6 is equal to y. But that's really not the original y. Remember, we swapped those, so what that is y inverse. And y inverse is equal to 2x minus 6. Okay. Example 2. Our first step is to swap x with y. So I'm going to put an x where the y is, and a y where the x is, and rebuild my function around it. So that was y is equal to negative y minus 4 to the 5th. Now I'm going to use inverse operations and solve for y. So first what I want to do is get rid of that negative out front and divide both sides by negative 1. So it gives me negative x is equal to y minus 4 to the 5th. Now I want to get rid of that 5th power. Well, the inverse of raising a power like raising something to a power is like rooting it, because rooting depowers things. So to get rid of that 5 up there, I'm going to 5th root both sides. So that cancels out. And I've got the negative 5th root of x is equal to y minus 4. And then I'm just going to add 4 to both sides. To get that y inverse is equal to the negative 5th root of x plus 4. And it's very important that you understand that plus 4 is not underneath the radical at all. It's outside. Okay, one more to go. Our first step is to swap x and y. So this becomes an x, and up there underneath all that mess is a y. So x is equal to the cubed root of y minus 2 over 2. Now in this one, I want to get rid of a radical first. So instead of depowering, I want to power both sides to get rid of the radical. So I'm going to raise both sides to the 3rd power. And those cancel each other out. So I've got x cubed is equal to y minus 2 over 2. Next, I have that number underneath that I want to get rid of. So multiply both sides by 2. And I have 2x cubed is equal to y minus 2. Add 2 to both sides. And I get that y inverse is equal to 2x cubed plus 2. And that is it. So remember, for inverse functions, in general, all you're doing is swapping x and y. That's really all you're doing. Okay.